Okay, here goes round two. I know that many of you had problems with the videos before, so I've tried a different approach here. Okay, we're going to use long division. Long division is really a pain, but it is necessary when you have a divisor that is not in the simple form x plus a number or x minus a constant. So if I look at this one and I need to do division, I notice it's x squared. Can't use synthetic. I'm going to have to use long division. So I'm going to draw my house. I'm going to write 5x to the fourth minus 3x. There's no x to the third, so let's make sure we put in a placeholder for the x to the third. Minus 3x squared plus x plus 1, and we're going to divide by x squared plus 2. Okay, so now I need to think, how am I going to get 5x to the fourth? Well, if I multiply by 5x squared, right? 5x squared times x squared is 5x to the fourth. I'll also have to multiply 5x squared times 2, so that would be plus 10x squared. Now, with synthetic division, with long division, you always subtract. So 5x to the fourth, that cancels, the 0 cancels, and we now have minus 13x squared plus x plus 1. What do I need to multiply to get negative 13? Well, that would be negative 13. Notice how I put the numbers in the right column. So x squared over x squared, 13 is in the constant column. So this is now negative 13x squared minus 26. Now remember, you're going to subtract, so I'm left with x, and 1 minus negative 26 is plus 27. So now I can write my final answer. This is my remainder. I am going to write it. This polynomial can be written as 5x squared minus 13 plus x plus 27 over x squared plus 2. Now, if you're a little confused about why we're writing it like that, let's think about it if we were just using plain old numbers. Let's say I had 37 and I divided by 5. Well, let's see, 7 times 5 is 35, remainder 2. 37 over 5 is 7 and 2/5. That's the same thing we are doing here. We're putting the remainder over the divisor. Like here, we put the remainder of 2 over the divisor of 5. That's the same thing that we're doing here. Okay, another example, I think I'll just do 2. I won't do 3. You can do that one on your own if you wish. I'm going to write 3x to the fourth minus x cubed, and I'm going to leave a 0x squared plus x minus 2. I'm going to divide by 3x squared plus x plus 1. So now to get 3x to the fourth, I would have to multiply this by x squared. So 3x to the fourth, that's plus x cubed plus x squared. Now remember, you always subtract doing long division. So that's gone. That is going to be a negative 2x to the third minus x squared. Bring down the x minus 2. Now this is a little bit more tricky. I want to get negative 2x to the third. Well, I think you all see that it's going to be negative an x. But what number should I use as the coefficient? I have to multiply by 3, but I want 2. We'll use 2/3, right? Whatever you divide it by, right? Because 3 times negative 2/3, right? The 3's cancel and you're left with negative 2. So that's negative 2x to the third negative 2/3 x squared, and that is negative 2/3 x. Now I'm going to subtract. Gone. This is now negative 1, right, plus 2/3, so that's negative 1/3. This is 1 plus 2/3, so that's 5/3, minus 2. So now I can do division one more time. I'm going to now, some way I need to, it's going to be a constant, right? Because I've got the x squared, but I need negative 1/3. 3 times what is negative 1/3? Negative 1/9, right? 3 times negative 1/9 gives me negative 3/9, or negative 1/3. So negative 1/3 x squared, negative 1/9 x minus 1/9. Go ahead and subtract. Now this is gone. Now here, maybe it's easier if we change this. We've got to have common denominators, right? So that would be 15/9, and this is going to be 18/9. I did that so I can do the actual subtraction. Okay, so 15/9 plus 1/9 is 16/9. Negative 18 plus 1 is negative 17/9. Okay, so now let's write our final answer. X squared minus 2/3 x minus 1/9. And then this is plus 16/9 minus 17x minus 17/9 all over 3x squared plus x plus 1. Now this is a little messy to have this complex fraction, so you probably want to multiply through by 9. So x squared minus 2/3 x minus 1/9. Now remember, I want to multiply top and bottom by 9 to get rid of the complex fraction. So I have plus 16x minus 17 over 9 times 3x squared plus x plus 1. And that would be my final answer. Let's go to the last problem on this page. This is the division algorithm. Let's return to our example, right? If I was doing, let's see what we decided up here. We were going to do 37 divided by 5. So this would be the same as writing 37. That's what I started with. I divided by 5, and I got a quotient of 7 with a remainder of 2. Right? 5 times 7 is 35 plus 2 is 37. We want to do the same thing with our function. The starting function is equal to the divisor times the quotient plus the remainder. So on this problem, they say that we want to use this, we want to write it in this form. K is negative 5, so really we're going to have x plus 5. So f of x is equal to x plus 5 times the quotient plus the remainder. So I'm going to set this up. X to the third plus 2x squared minus 5x minus 4, that's my function, and it's divided by x plus 5. Okay, so let's do the long division. This would be x squared. Go ahead and subtract. You get negative 8x squared. Now I need to multiply by negative 8x. Now remember, you're subtracting. So negative 5 plus 40 is 35x. And now I'm going to multiply by 35. And let's see, that would be 35x plus 25, 175, that's negative 179. Okay, so now I'm got my remainder. So I can write this function is f of x equals x plus 5 times x squared minus 8x plus 35 minus 179.